All right, guys, today we got a special one. We're talking about the Q12 OptimScan. Is it OptimScan? Q12. Now this is a next level scanner. We've got our couple of hobbyist scanners, and then we've got our reverse engineering scanners like the HX2 and the H2, and then we've got a professional line of the metrology scanners like the free scans, but then there's a whole nother level to all that, and that's the OptimScan line. And these are for like aerospace grade inspection. We're talking 5-micron accuracy. And was it 4-micron point distance?
40-micron point distance.
40-micron point distance. Now, this will come into play in very, very, very tiny details and whatnot, and inspection for very precise machine parts and things like that. But we're going to go over all the features and sort of give you a rundown and a little bit of the workflow of these units, and they start around 50K. So if you're familiar with Keyence or maybe the GOM station scanners, like they're big, heavy, hefty optical scanners for really high-end scanning. That's what this is for today. So if you're in the market for that and you got the budget, definitely watch this video. And if you don't, just watch this video for fun because it'll be really interesting. Eric, great to have you in again.
Thanks for having me back.
Always a pleasure. You bring a lot of great knowledge and stuff for us and everybody watching. So the OptimScan Q12. What's the biggest thing that sets this thing apart from the competition, from the other scanners, etc.?
So if you looked at the Shining3D portfolio and follow along with VisionMiner's videos, you'll notice we have the OptimScan line, the consumer level scanners, and prosumer. And then we have the FreeScan line, which is more for the higher accuracy laser scanning systems. And then this one here, the OptimScan, is a blue light, structured light projection scanner with dual scan range for capturing parts for inspection. And it's able to capture those really fine details, really sharp edges, which is inherent to the structured light projection type of scanners.
Yeah, like we've always noticed over the years, using a FreeScan combo with the blue lasers gets you really high resolution, really great detail. But even then, if we want like the super fine surface finish and texture of like leather, like fine grain leather or something like that, the Pro HD and the structured light just kind of has an advantage, right?
Exactly.
So similar here for that ultra high detail, then you're using structured light and optics.
That is the benefit. So a lot of cases in inspection workflows, if you have like a notch on a part, it's a bit harder to capture that with the laser type of technology. But with the structured light projection, you can really get into those type of dents and notches and capture that for the inspection workflow.
You mentioned dual scan ranges. Can you talk a little bit more about that?
You see on this unit, there are 4 cameras.
1, 2, 3, 4,
Yep.
and then a projector in the middle?
Yep.
Okay.
And those are all 12.3 megapixel cameras.
All of them. They're all 12.3
Exactly.
megapixels.
Yeah.
Okay.
So when we say dual scan range, we have a precise mode for capturing smaller parts in higher resolution from 0.04 millimeters to 0.12 millimeter point distance. And then we have a wide range, which is for capturing larger parts up to the size of, say, like a basketball, between the point distance of 0.1 to 0.3 millimeters. We can also combine these two modes together. So you can capture areas of a larger part with the precise mode for those smaller features. And then you can capture the overall geometry and other areas that are smooth and flat in the wide range.
And it'll do this at the same time, or you do these scans separately?
Separately. So you can switch between modes.
Got it. And then
that's a system,
combine them.
Exactly. And that's a feature that's been highly requested throughout our years of developing these 3D scanner units. And so we have them in the FreeScan units, being able to switch between modes. And now we've brought it over to this system here because this is what you want in a full inspection solution. Being able to capture high detail, but also a larger area without losing accuracy.
Now you mentioned that this is a turntable-based scanner, right? Can you do scans without the turntable?
You could. So if you follow along with the OptimScan Pro Series units, you'll notice we can take single shots and align by either markers that are placed on the object or by features.
So you can set it basically, I mean, you see it comes on this hefty tripod. Like this thing is really, really big and solid. And so you can either use the turntable. By the way, the turntable, this is a heavy, what is this, like 15 pounds, 20 pounds probably, and it can hold 45 pounds of weight. Is that correct?
Exactly.
So not quite scanning people, but this thing will handle that weight and still move in super precision. Does this also do 180 degrees? So it'll do 2 degrees per rotation, up to?
Up to.
Now you don't usually need that, right? But you can.
You can.
Okay.
And you can actually set the angle that the turntable is rotating.
And then if it's bigger than will fit on the turntable, you can use the tripod, point it at your object, and then you don't even have to put markers on it. You can just scan and then move it around, scan there, and it'll align those, or I mean add markers for better accuracy and better alignment and all that. So it does serve both, okay.
We always have methods to do different types of alignments. When you want higher accuracy scans, it's always nice to use markers.
Yep.
But if it's just for the overall geometry and shape of the part, then you can just align based on features if it has enough detail for that.
Yeah, so there's different workflows. If you are like, well, I don't need perfect accuracy, you can go faster. If you are like, I need the exact best possible detail, then you do a little bit more. Makes sense. Now, MSF, let's talk about monocular stereo fusion. This is one of those big hype features that really makes a big difference now. Give me a little overview on that.
Monocular stereo fusion is a fancy way of saying that it takes 3 shots in one, but at the same time, it's really useful for capturing parts that have holes or cavities, deep recesses, because the scanner is actually using each camera to capture a specific area. You'll notice that if you use both cameras, if you use stereo vision to capture a part, both cameras have to see that surface in order to collect measurement points. But with monocular...
It's triangulation, basically.
Exactly.
Seeing it, okay, I know there, okay.
But with monocular vision, the triangle becomes from just one camera. So it's able to see some of those areas that might be hitting by ribs or walls, which the other camera won't be able to capture.
Yeah.
So again, taking 3 shots into one, and that just makes it a lot more easy to capture those complex, deep recesses, cavities type of parts in just one scan.
That is interesting because, like, on a lot of the scanners, especially the laser scanners, right? You have 2 lenses that are about a foot apart, and I can only scan areas that can be seen by both lenses, right? So this sort of does some software magic and makes it so that, well, I've got 4 cameras, I can actually get data from this one, get data from that one, get data from that one and that one, and it can have some advantages for like deep holes and
Exactly.
Yeah, interesting. This is the calibration board.
For wide mode.
For wide mode. This is a little bit bigger and a little bit different from the rest of the scanners, and it comes on its own tripod. Tell me about the process.
Even when you're considering a system like this, which has such high accuracy, first thought you would think of is, what is calibration like? Is it really hard? And it probably is. But the nice thing that we've done is that we've made the calibration process really easy by telling you exactly how you need to place the board at each step, so that you don't have to figure out on your own if the cameras are looking at the right spot. We're going to tell you how to move to the left, to the right, whether you should tilt it upward or downward, and give you the exact position that you need to put the board. So it only takes around 2 to 3 seconds per step. And you can finish the calibration, the standard calibration, in 5 to 6 minutes. For the quick calibration, you can do that within 2 minutes.
And is that after the first time? I heard the first, we did some calibration yesterday, and the first time can take a little extra time, right?
Exactly.
The very, very first time.
So the very, very first time, you're just kind of figuring out how to position everything, so that will take a little bit longer.
And you're moving the ball head around to get the angles and everything, right?
Exactly. You can see we provided the tripod and also the calibration board. The software will run you through it step by step, and we've got a lot of feedback on some previous scanners that we've had on how to make the calibration easier. So we put a lot of that into this unit here, and we're getting a lot of good feedback on how easy it is to use or to do the calibration. So we're really proud of that.
That's one thing here at Vision Miner. We sell all these products, right? All these 3D scanners, but we actually use them every day and we train on them. If you called right now and were like, hey, I'm interested in your FreeScan Combo Plus, right? You'll probably talk to Alonso and we'll bring him in. But he's like, yeah, the first time calibrating takes a little bit longer, but then it's super easy and super quick every time after that.
Yep.
And that's always good. You don't want to spend your time scanning, not setting up. When it comes to shiny or black objects and whatnot, this unit has some special features, almost like HDR in photography, right? Where it does multiple exposures and whatnot. How does that give an advantage when doing shiny, reflective, dark, black objects?
We have a multiple exposure setting especially for that purpose. Because this is not a laser scanner, it uses blue light technology. It does have a little bit harder time to capture black or reflective surfaces. But the way that we've compensated for this is by providing a multiple exposure setting. So there's an automatic exposure setting that just uses one brightness setting to capture a part that has like a single color. And then we have a single, double, and triple exposure setting for capturing parts that have like black on one end or shiny on one end, and then just different color profiles around the part. There's also a customized exposure setting where the scanner will actually look at the part beforehand and try and figure out what's the best exposure for individual areas of that scan.
If you got an object with, some parts of it are polished metal and some parts are, maybe a matte paint or whatever, on any other scanner I'm going to have to scan and then, oh, I'm missing data. Let me adjust my brightness, scan. Okay, adjust my brightness again, scan more.
Exactly.
This sort of automates that.
Yeah. So we try to make it a very quick solution for any type of parts. We give you the option to do HDR, multiple exposure settings to capture the part. So if you looked at some of our other units too, like the iScan Pro HD or the iScan SP, you'll notice that we have that HDR setting on those units. This one brings it one step forward, where we would do more exposures for the part and also try to figure out on its own what type of exposure is necessary for different.
It can do 1 or 2 or 3 exposures, or auto, where it'll actually pick multiple at different, depending on what data it gathers. It's then like, I'm seeing data here at this level, at that level, and then it picks the best and then fully automates that process.
Exactly. So you can see we tried to make the scanner as simple as possible for the user, for the engineer who's capturing the parts. And this is one of the settings that we found makes it really easy for them.
How's this compared to a ferro arm? Because everybody I've talked to who has a ferro arm they love it, but they hate it because they're like, dude, every time I have to use it, the setup is so ridiculous. And like just going through that is a physical touch point, off thing. How close are we getting to that kind of accuracy with something like this?
So this can get down to 5 microns accuracy.
That accuracy is absolutely nuts. It's really, really, really good. 5 microns.
I also want to point out that we do get a lot of customers, right, who use the ferro arm, and they'll come to us, and they're looking at a 3D scanner because they just don't want to move the rover arm around to scan those medium to larger objects.
Yeah.
And the thing is that you can't really use the rover arm for reverse engineering because you can only capture a certain amount of points. And that number is just not enough to get a very usable model for getting sketches or references for recreating the part. The key thing about having an optical unit like this, 3D scanner, is that you're able to capture millions of points.
Yeah, all at once.
All at once.
Instantly.
And all of that data combines with the capability to capture deep recesses into parts and all the individual features and sharp edges, gives you a lot of detail to work with when reverse engineering. That is the main point where customers who have the rover will come to us and say, I need something that gets a lot of data very accurately. What's the best scanner for that?
Yeah.
And that is what we tried to do here with the OptimScan.
And it is significantly faster than touching off a bunch of points. You can scan it and then touch off for verification, but still, it's night and day. We had one customer they were making nuclear power plant like caps for these nuclear we have a whole video on it, scanning it with the HX2, and they complained all day. The entire demo, they were complaining about the ferro arm and just how long and how difficult and how, and they were blown away by the ease of use of just those handheld scanners. But if they needed this accuracy, again, it's the same concept, instant results, very, very fast. Shining3D, you guys have always been known for your just intuitive software and the workflows that are just easy and straightforward, and compared to most of the other companies, just a better software experience, right?
Exactly.
So when it comes to things like aligning multiple scans or working with the data, should we expect the same sort of type of ease of workflow and whatnot?
Yeah, exactly. So if you've seen the other videos, you'll notice that we have tools to make alignments based on features, based on markers, and also based on the turntable. All of that is included in the scanner. But the one thing that's different is that we do it automatically for you. There's more of an automated process with this software. So primarily when you use the OptimScan, you will be aligning based on markers for higher accuracy.
Is that markers like the turntable markers or on the part?
Yeah, so
Or both?
either case. When it comes to thin-walled parts, you always want to put markers on the part for the highest accuracy. If it's something that has more geometry, more surface area around the edges, then having just markers on the turntable would be fine. The improvements that we've made to the OptimScan, one, we will automatically make a cutting plane for that turntable. So anything that you scan on the turntable, that data for underneath will be automatically deleted. And then when you flip over the parts and scan it in multiple positions, that data will also be automatically combined together so that you get the 3D model after just doing 2 or 3 projects, 2 or 3 scans.
2 or 3 projects, each scan set of data. So like, say I did a scan in this orientation and then that orientation, those are referred to as projects.
Yep.
Right, but it's all within one project.
So we brought basically all of the tools from what we've heard from feedback from customers beforehand and integrated into the FreeScan software, iScan software, into this one. But we also made it a bit more automated in that we improved on how much cleanup that you have to do to work with the scan before being able to create the STL.
And how much cleanup are we talking? Is there a lot of cleanup that needs to happen, or processing things, or is it automatic cutting plane? That's been a manual feature for years now, but it is pretty much like, oh, get rid of the surface that I scanned on. So now that's just been like automated.
Exactly.
Okay.
And it goes into play with some of the other things we talked about, like the monocular stereo fusion.
Monocular stereo fusion.
Then,
say that 3 times fast. Monocular stereo fusion. Monocular
stereo
all right.
fusion.
Yeah.
And the dual scan range. So being able to capture all of that data within one project and then being able to switch the scan ranges so that you can do precise scans of small areas and then scans of the overall part merely makes it so that you have a really quick process of placing the part down the turntable, setting up those parameters, and then having the automatic cutting tools and post-processing tools so that you get the full 3D model.
And that's everything at the end, like the simplification or hole filling or all those different things for messing with the data. So if you got markers on it, you can automatically fill holes and everything before you export the mesh file. Right?
Exactly.
Or the point cloud or whatever you want to do.
So we have some of those tools for mesh editing, optimization, smoothing, simplification, removing small floating areas, and then reducing noise and
Connected
spikes,
yeah,
and stuff like that. So
connected domain.
exactly. For each step, we either give you very optimized data for inspection or reverse engineering purposes, or you get the raw data, which you might want to use instead for inspection.
So one of the little things that we've experienced in the past that's been mentioned is that, like, you know, you've got a scanner on a tripod and then you've got a table with an object, or sometimes the object will kind of have a little kilter or something and you want to, you know, fixture it down with sticky tack or something, but sometimes your whole table's moving, etc. So to get the super high-end precise accuracy, it actually notices if there's any movement whatsoever and it waits to scan, right? So if you bump the table during a scan or something like that, it'll negate that.
It'll negate that. It'll tell you that something's moving and that's not right. And we want to retake the scan. So it's going to automatically do that for us.
Little quality of life workflow things, just everything from the years and the suggestions and the ideas being flowed into all the product lines. That is one thing we love about Shining3D, is that they're constantly updating their stuff. We get software updates every couple of months that are just automatic. Oh, hey, look at these new features, new products, new innovations, everything.
And that is the strength of Shining3D, being able to innovate very quickly based on what we see in the market and what customer needs. So we are one of the only companies that are able to innovate that quickly. So if we have a scanner that's we see has been in the market for quite a long time and there hasn't been any improvements to it, Shining3D will look at that and be like, oh, we can do something different with that. We can make it better and spend some time to develop that and get a product like this.
Well, and as a company, I mean, it's in the name Shining, right? So that probably came from shining light, you know, that idea of scanning and whatnot. And as a company, you're from the hobbyist range to the ultra professional range, you're entirely focused on 3D scanning, digitalization, metrology, etc., which means they don't do sales, which means you come to visionminer.com/scanners and you can see the entire lineup of Shining3D scanners. We support them. We use them here every day. We're actually here to help and just answer your questions to see which one you should get. Come to us, ask us. We're here to consult you, get you the right machine depending on what you're actually doing. At the end of the day, which scanner are you buying? It depends what you're doing and what the results you need are and what's the output. So for a scanner like this, it's definitely in that business budget range, around 50K. Who are we really going to see buying this thing?
This scanner is for the people who really need tight tolerances on parts.
Tight tolerances.
And that could be either for reverse engineering or inspection. So the main customer that we'll probably see is for aerospace, in the case where they need something that fits airtight.
You guys seen those machine parts where it's like a block of steel and they do the wire EDM machining for super precise accuracy, and the block will have a cylinder cutout and they'll take a cylinder, drop it down, and it'll like bounce on the air inside. Right? So that's a 3 to 5 micron tolerance. Anything less than that and you're sticking, anything more than that and it's a little bit loose and it drops. So those kinds of tolerances, airtight tolerances.
Exactly.
That's wild.
We're getting pretty close to that.
Cool. What kind of things are they going to be scanning? Like anything and everything? Can you give me a couple real world examples?
Well, the OptimScan is really designed for tight tolerance machine components that are made for the aerospace industry, medical, or automotive.
This could be validation, inspection. Okay, so high-end aerospace, medical devices, maybe some oil and gas, really, really high-end stuff. I mean, these are the guys that are going to utilize the whole system. They have a whole system where you can put this on a robot arm on a whole track and it can move around, scan, 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 stuff like that. I mean, we're talking high-end, bigger scans. I mean, this is next level
Just to
stuff.
make it more automated. Batch processing of parts and end process inspection.
First thing, just give us a call, shoot us an email, something like that. We'll answer all your questions, or even leave it in the comments below, and maybe we'll feature you in a video in the future. Thank you so much for watching. Have a positive rest of your day. I'll see you on the next one.